Okay, we're looking at the Unit 1 Lesson 10 through 12 quiz, and this is the explanation video for how you do the problems in the quiz. So the first question that we had says we need to find the inverse of the relation, and we have the points 10, -1, 7, -4, 12, -3, and 10, -8. So hopefully remember the inverse of a coordinate point is just flipping the order of the two values. So the first point would become -1, 10. The second point would be -4, 7, and so on. So we'd have -3, 12, and -8, 10. And whenever you're doing a relation, it's really important that you add the curly bracket things on the beginning and the end of your set of coordinate points. Okay, for question 2, we are asked to find f times g of x for the two functions, so it means we're multiplying the two functions. So the first thing that you want to do, we're going to be multiplying the two. I'm going to put up a code for writing out the multiplication of the two problems. It'll take me a second to type this in. Okay, so that's what it's going to look like. We're multiplying the two things together, and then we're going to use the distributive property to multiply out all our terms. So I'm going to do the 9x squared times each of these, and then I'm going to do the -3x times each of these, and then I'm going to do the -5 times each of those. So this is what that would look like. 9x squared times 7x is going to be 63x cubed, and then 9x squared times -7 would be -63x squared. Oops. Okay. And then we were going to do the -3x times the 7x, and that's -21x squared. And then -3x times -7 is +21x. And then -5 times 7x is -35x. And -5 times -7 is +35. And so from here what we need to do is just combine our like terms. There is only one x cubed value, so that can be combined with anything. That's going to stay the same. We'll still have 63x cubed. Then if we look at our x squared values, we have a -63 and a -21, and together that makes -84x squared. I'm going to write it there. Let me write it over in my code area. And then I have +21x and -35x, and when I combine those, that's going to give me -14x. And then I have a +35 on the end. So this last step, that's our answer for question 2. For question 3, we're asked to find f plus g of x. We're just adding the two functions. So we're looking for all the x squared terms, and we only have 2x squared. That's the only x squared term. Before that, let me put my expression for f plus g of x. F plus g of x equals. Okay, f plus g of x equals. So we have 2x squared. Then we're looking at all the x terms. We have 9x and 7x, and together that makes 16x. Got my plus sign on there. So plus 16x, and then we have +6 and +3, and together that makes a +9. So your answer for number 3 would be 2x squared plus 16x plus 9. Alright, for number 4, we're getting into composition now. We're doing G composition H and H composition G. So I'm going to do G composition H first and see what that equals. So G composition H means G is the outside function, 6 times x. So I'm doing 6 times something. So the something is the h function, so I need to copy this h function in, and I'm going to have to retype that out. 9x to the third plus 11x squared minus 7x plus 3. And what I have to do now is distribute this 6 to every term inside. And so when I do that, I'm going to have 6 times negative 9, which is negative 54. I'm going to have 6 times 11, which is 66. I'm going to have 6 times 7, which is 42. And I'm going to have 6 times 3, which is 18. And so this right here is my final answer for G composition H. For H composition G, now we have H as the outside function and G as the inside function. So we're going to start with H. So that's negative 9 times something. That something is the G function. It's 6x. 6x to the third power. Let me code that up so it looks a little bit better. And then I have plus 11x squared. So I'm going to say plus 11, but instead of x, I'm now plugging in the G function, which is 6x. So now instead of plus 11x squared, it's plus 11 times 6x squared. And then I have minus 7 times x, but instead of x, I'm plugging in the 6x again. So that's going to look like minus 7 times 6x. And then I have just plus 3 at the very end. So what I have to do this time is I'm going to do 6 to the third power times negative 9, and then x to the third power. So 6 to the third power is 216, and 216 times negative 9 is negative 1944. And so that's going to be times x to the third power. Then I have to do 6 squared, which is 36, and multiply that by 11. And that is 396. And this is the x squared term. And then I have 7 times 6x, which is minus 42x, and then plus 3. And so this right here, all this, that's my H composition G function. Okay, I'm going to push number 5 down to the next page. Okay, for number 5, we have to determine if the functions are inverses of each other. And the real simple way of thinking about if things are inverses of each other is if we can do the composition of the two of them. So I want to do F composition G, and I need that to equal X. And at the same time, I'm also going to do G composition F, and I need that one to also equal X for each pair of functions. I need both of these things to be true. So for pair number 1, let's start off with doing F composition G. So when I do F composition G, I'm taking F as my outside function and I'm plugging G inside of it. So when I see this X right here, the basis of my function is 5x minus 6, but in place of X, I'm going to be plugging in the G function. So I'm going to leave some parentheses and then I'm going to plug in my G function. So give me 1 second and I'll be typing that in. Okay, I know the formatting's a little bit bad for that. But so what we're going to do here essentially is 5 times a fifth, those cancel out. We're left with x plus 6 minus 6. And obviously the plus 6 and the minus 6 cancel and you're left with x. So the F composition G, we got just x. Now I'm going to do G composition F. So I'm starting with G as my outside function. So I have 1/5 again. Times, in parentheses, I've got x plus 6, something plus 6. That something is my F function. which is 5x minus 6, and then the plus 6, close parentheses. Hopefully you can see inside here, minus 6 and plus 6 cancel out, so this is just 1/5 times 5x. And again, 1/5 and the 5 cancel, and we're left with just x. Because these both gave me x, that tells me that pair 1 are inverses. And now I'm going to look at pair 2, and I'm going to try to do the compositions again. Okay, so I'm going to start off by doing f composition g for the second pair. So f is the outside function, that's 12x plus 13. In place of this x, I'm plugging in the other function. So the other function is 12x minus 13. So I have the expression 12 times 12x minus 13 plus 13. And if I distribute this 12 times 12 is 144x. 12 times 13 is 156 plus 13. And hopefully you can already see that this is just 144x minus 144. That did not equal x. So I already know that these are not inverses, so I can just immediately come down here and say pair 2 are not inverses. When I did the composition, I did not simplify down to just x. Okay, for number 6, we have coordinate points. We're doing composition again. So we're going to start off with f composition g, and that is going to be some set of coordinate points. So if I'm starting off with f, let me start off with the value of -4. And -4 goes to -5, and then I plug -5 into the g function, and -5 goes to 0, so my ending value is 0. Then I go back to f, my next point starts with 0. 0 goes to 3, and then I come down to g, 3 goes to -4. Alright, and then we're going to look at the last f value. So we're starting at 1, 1 goes to 6, come down to g, 6 goes back to 1. So we started with 1, we ended up at 1. And so those are my points in f composition g, and then we have to do g composition f. So for g composition f, we're starting with g and we're going to f. So we're starting with the g value of 6 first. 6 goes to 1, come back to f, 1 goes to 6. So we started at 6, we ended at 6. Next value in g is -5. -5 goes to 0, and in f, 0 goes to 3. So we ended at 3. The next point in g is 3. 3 goes to -4, and -4 goes to -5, so we ended at -5. And that is g composition f. So we're picking up with number 7 now. Number 7 says we have g of f of 8. So we're starting with f of 8. And f function is x squared, so we're doing 8 squared. And obviously 8 squared is 64, so we're actually plugging 64 into the g function. And g of 64, the g function is 5 times x. And our x value is 64, so we're doing 5 times 64, which is 320, and that is your answer to number 7.